We're about to go into some serious functionality building for our application. So before we do, let's consider what we've got so far in terms of structures. Now, I've told you before that what we will do is we will use a UML, that's a Unified Modeling Language Diagram, which is what you see in front of you now, as one of our main design documents, and it's terribly powerful in terms of giving you a better grade because it really does show that you're implementing planning in your application. So here's the structure in what we've got so far on the screen. So we've got our import data, which is where we get our database file data from. And then we've created user and user DB. Now the user DB class uses users. And similarly, what we're about to build is we've built the loan, but we're going to try and build now the loan calculator. Now in here you can see a really perfect difference between the two types of classes that we create. Now our loan is a data-only class. There's the data members, the price, the deposit, the term, and the rate. Whereas our loan calculator is a method-only class, it's a factory class, which has no data, but will use loan data to calculate monthly payments, annual payments, weekly payments, whole payments, based on the price, the deposit, the term, and the rate. So that's a typical structure that we would use, where we would say, what we've got is we've got this loan structure, which sits on its own, does one job, describes the nature of the data that's held, and this is what we can do with that in order to give information back from that data. We'll eventually move on to the running cost and the running cost calculator, but we haven't got there yet. So before we start to design it, I've just put it in place, a placeholder in our diagram, and you'll see that that's how we're going to approach the development. Same as these is what we'll do here. So here goes the usual thing. What we're going to do is make the loan calculator, and we're going to do that by doing that. Add at the bottom, and it's going to be loan calculator, all one word, no spaces. Loan calculator. We're going to make it public. Nice space in there, and then commentary at the top. So I've pasted in the header factors there, so it's a loan calculator, that's me, today's date, and then what we're going to do with the methods only. Right, so it's going to be a method only, so we won't be declaring any data members at the top, so we'll just be creating functions. One of the easiest ways to approach this particular problem that we have is, because we have to work out 4 different values, is to calculate one and then use the basis of that for the calculation of the others. Now in this case, I think the easiest one to use is the monthly calculation. So I've worked out the formula for working out the loan payment on a monthly basis. Now when we do that, we can then derive all the other values from it. So the annual basis is easily derived, of course. The whole basis is easily derived because we've got the annual and how many years the loan is going to last, and so forth and so forth. So I wanted to introduce you to one concept, and that's the use of a constant. So what a constant is something that we can put inside the class, and it can be used by any method within that class because we've got it inside this particular class. Now we've declared it as private to show you that I'm encapsulating this particular value, and it may be good to point out that value in your essays and your reviews, is that you've encapsulated this value. It's private inside here, so no other class can use it. So we're naturally, you're going to try and take advantage of explanations that say we're using OOP, and that's where we're doing an immediate encapsulation. So that can't be touched by any other class because it's private inside loan calculator. So what we're going to do is we're going to create our first method, and that's going to be called loan monthly payment. So what I want to do with this is I want to do exactly the opposite of what I've just done with the encapsulation above. I want to make this public. So public, and I want to make it static because that means that the value of this that it's going to produce can be carried across from one function to another, and it's going to be openly available for us to use throughout the application. And the value of the return I want to use is called a decimal. That's a number type, as you know. It's a very large capacity number type with a very high level of precision. And I'm going to call my my method loan loan monthly payment. And the value that I need in order to work this out is a loan type. We've got loan, which is a public class. And I'm going to give my variable, I'm going to refer to it as my loan when I use it. So that's what we call the method signature. So I've got that now. And I can now create all of the calculations inside this particular method that will allow me to get the monthly payment. So that's the first step. So the first thing we need is a value, a variable, that will hold the data that we're working from and the value that we'll eventually return by using this method. So I'm saying that we're going to say payment. That's going to be what's eventually returned, because it makes sense to call it that, because that's what we're calling the function, loan monthly payment. And we'll probably use the same variable name when we move beyond into annual and weekly and so forth. So that's what we've got there. So we've now got a variable that can handle the payment for return. Now I've made it a double. I'm going to call it payment, and then we set it up, we initialize the variable to equal 0. So that's a very good start. And now what we need is some variables that will hold the values managed by the class and adjust them to our needs so that we can work out what the payment is going to be per month. So I've got them on my clipboard, and I'm just going to paste them in and then talk them through for you. So that's what we'll do one at a time. So I'm creating local variables, and these are going to be what we're going to be using from the argument class. This is the argument class, the loan that's coming in. Now it's quite interesting. What I've done is this is actually the accepted or the recommended way of declaring the return type for a variable, var, var. And what C# is really good at is it's allowing you to work with explicit conversions between different data types by saying var. So I'm saying here that the loan term in months is whatever my loan has as term in years times the months per year, times 12 in this case. We're saying that the loan interest rate is going to be convert to double my loan rate. And it's going to be that the loan amount is my loan car price, whatever the value of the car price is that we've given it. And we're going to say it's my loan car price minus my loan car deposit. So that makes sense, is that the loan amount, we want to borrow whatever the car costs less whatever deposit we're going to put down on the car. So that's us now got all the variables we need in order to work out how much the monthly payment is. So we're going to work out the value that we need to return, but we need to base our value on two conditions. We want to make sure that the loan term in years, which is here, isn't equal to 0, because that wouldn't make sense to work that out at all. And we also want to make sure how we're going to handle it if it's an interest-free loan. So we need to still work out how much it's going to cost per month and so forth, but we're going to do it very differently because no interest is being charged. So what we need to do is we need to create up what's called a nested if. We need to set up a nested if. So the first nest we're going to do is this one, which says if my loan term in years is greater than 0. Now what we're going to do is we're just going to do a straightforward, sorry, that's wrong on that. So there's our nest for our code set up in there. Then we'll put the second part of the checking system that we're going to do inside this if. So the second check is this. So we're going to say if my loan rate is not equal to 0, that's the bang equals, that's the not equals to. And we're also going to put an else of what we'll do if it is, because that's when we'll work out the loan calculation. Now for the actual mathematics of this, you're just going to have to trust me. It took me ages to work this out. And to be honest, I really just don't think you need to understand. You just need to be able to use it. What it does, it uses a built-in library called Math, which is available to all C#. Uses a built-in, well-constructed library which has a vast array of functions that are already built and tested. So we can actually use that in order to use a math to the power of, and that's what our calculation is based on, something to the power of something else. So let's get that code ready for this first branch in here. So let's paste the code in to do that. So this is saying that if the loan rate is not equal to 0, the rate, I've created another variable called rate, which is double interest rate divided by number of months per year. And that whole sum is divided by 100. The factor is this. That's what it's using the math library here, the math.pow, which is there. Just don't worry about it. That's what it is. That's how it does it. Okay. So when we need to put the rest of the values, well, okay, what is 0? What will we do in the case that it is 0? And that will go inside here in our nest. So if the interest rate is 0, that's what we'll do. We'll say that the loan amount, the payment, that's what we're going to return from this function, remember, equals the loan amount divided by, forced to double, the loan term in months, because you can't divide this by the int that we've got here. So that's what we've got to do, because the payment is a decimal return. So that's how we do that. You're going to have to trust me on this, guys, because it just is what it is. Okay. Now it says there's a little warning there. It says that because we're going to floating point numbers, there's a potential loss of precision. But don't worry, we're going to handle that because it's fractions of a thousandth of a penny that we're worried about there. So it's of no concern to us in this particular situation. So what we'll do finally is we'll do a return value for our function. So the return value is going to be whatever the current value of payment is, either from here or from here in the two different circumstances. It's not equal to 0 and it is equal to 0 as a loan rate, and we'll return that value. So where we're going to return that value is outside this if. So I'm going to paste it in there. And now we're going to return a formatted number. Okay, so we're going to return whatever the value of payment is, and we're going to wrap it around this math round, which rounds it up to the nearest factor that we've set. And we're going to say it's a decimal of the payment. So we're turning decimal into whatever we're forcing the value of a decimal. And we're saying 2 decimal places by putting this payment, comma, 2. So that's our function. You just have to trust me on this. And that's going to give us the monthly amount that we would repay. That's our monthly payment based on the loan class that we've given to this method. So you just need to accept me on this, and it does work, and it gives an accurate value. So I think what you should do next is you should be putting your own comments in this code. Maybe don't copy mine exactly. Try and make your own. I think it would be appropriate to go in front of this, and in this particular one, do the ///, and we get the summary. So we'll say that this is the monthly payment. And what we'll do next is, because we now have this, we can work out everything else using this method. Exactly the same system. We'll just manipulate the numbers we get back from a monthly payment to give us the payments that we need for a weekly payment or an annual payment and so forth, and the total cost. So that's really good. We've got this one up and running. So of course we build a solution, and we hope for a success. And what we'll do next in the next video is we'll build the other 3 methods.